Good morning, everyone, and welcome back to our webinar series. As usual, we'll get started in a couple seconds. Some housekeeping as always. The webinars are recorded, and there's a PDF of the presentation available later in the day or first thing tomorrow morning. Also, you can ask questions, and we'll get to the questions through the question feature later in the presentation. A reminder, there's a presentation tomorrow by Alberta Energy on the new site rehabilitation program. And we just announced a new one for kids and families with Brian Keating next week. So if you want something to do with your kids for an hour, Brian's kind enough to do a presentation for us. So today's webinar is about the Soil Sterilants Program by Bonnie Drozdowski at InnoTech, Alberta. And today's webinar is sponsored by Core Environmental Consulting. So thanks to Bonnie and InnoTech and to Core. So what I'm going to do is I'm going to turn it over to Bonnie and she will take over. Just give me a second. And I will be back for the questions part. Bonnie, do you have control?
I do. I have to just pick the screen I want to show. All right. So hello, everyone. I'm going to shut my video off while we're doing the presentation. Joe tells me that that's distracting, and I won't have any children running in today, but usually that's what happens in this for me. So that's probably for the best. Joe did let me know how many people were participating and gave me some indication of who was joining. So that's pretty exciting. It's a big list of people, and I'm thrilled to be able to share this program with you today. So Joe, can you confirm that you can see my screen?
Sorry, we can see your screen.
Yes, okay, yeah. Awesome.
Yeah, if you can make it full, yeah, it's good.
We're good?
Yeah.
Awesome, okay, thank you. Okay, so today I'm going to give you an overview of the Soil Sterilants Program. So this presentation was given at a recent workshop that was hosted by Smart Remediation. So it doesn't differ from, too much from that presentation in case there's any overlap with folks who had participated in that event. But I'm really pleased to be able to present it to a broader audience today because this is a program that is pretty near and dear to my heart. And I think that it's a really great example of how we can bring multiple stakeholders, service providers, and groups together to achieve a common outcome. So this Management of Soil Sterilant Impacted Sites program is very program orientated, and it's been started for a little while now, but I just want to give you guys a heads up that Simone Levy, who's participating in the webinar today, is going to be instrumental to program management moving forward. And so if any of you have any questions about this afterwards, I would encourage you to reach out to either of us, but for the most part, Simone afterwards as well. So let's get started. I just thought I'd give you guys a really quick overview of InnoTech to begin with, because I know that there has been a lot of confusion out there about who InnoTech is, where it fits within the innovation ecosystem, and how they're linked to Alberta Innovates. And so it pains me that we have to do this at the beginning of the majority of our presentations, given the longevity of the organization, but I want to make sure that it's as clear as possible. So many of you would recognize the logos that you see up on the screen here. So InnoTech is an evolution of what used to be Alberta Innovates Technology Futures for a few years, and for a long time before that, the Alberta Research Council. So we're a wholly owned subsidiary of Alberta Innovates, and I'll give you some context as to what that means. But essentially, InnoTech is a research and technology organization that has been established by the government of Alberta to serve the needs of industry and the innovation ecosystem and academia. So what we're essentially been set up for is that the government intended for us to share the risks, accelerate initiatives, and remove barriers by providing a venue, so that's facilities, equipment, and expertise for industry and government to invest and conduct industrial scale research, technology development, and innovation in. So our mandate is really about demonstrating value to our clients and to industry so that return on investment makes the most sense from our clients' perspectives, as well as operating on behalf of our stakeholder, which is Alberta Innovates. Because we are owned by them, we do have the good of the public in mind for the majority of the projects that we are working on. So it's a very unique place because we're owned by government, but we work for industry and clients on their behalf. So we're uniquely positioned to provide services where others can sometimes be lacking in capability and capacity. So if they don't have the expertise or the resources from a facilities perspective or the ability to scale to an operational level, that's where we're uniquely positioned to be able to operate. We're also in the position where we generally operate in an area where companies are either unwilling or not able to assume the risk. So we have a higher risk tolerance than the majority of our clients, and then neutrality. So where our clients may not be able to do something without a conflict of interest, given that we're an arm's length government organization, that's sort of where we fit. And I give you this context because I think it's important for an understanding of how the Soil Sterilants program evolved and why we are in the position that we are to be able to manage it. So before we go into the program in too much detail, I wanted to give you a little background in terms of definitions, because you have to understand what a soil sterilant is before you can understand what its challenges are. So soil sterilants are defined as non-selective, persistent, residual herbicides that render a treated soil unfit for plant growth. And so here you can see that what that means is that if it's non-selective, it's used for total vegetation control. It's residual, which means that it's meant to control vegetation over the long term, and it's persistent, which means that it is supposed to be prolonged over a long period of time, and it's very much related to the chemical characteristics itself. So a long half-life, and that influences that can be accelerated by things like application rate and the environment with which it's applied. So why do we care about soil sterilants? What's the problem? What are we trying to address? So in addition to the chemical characteristics that I just gave you definitions for, the challenges with soil sterilants is that they were typically applied at high application rates over multiple years. They were generally applied at older sites. So there's a whole suite of different types of facilities and areas where this was applied. But full disclosure, these products are not supposed to be used anymore. And so for the most part, the sites haven't received these types of products since the 90s. That's essentially when sterilants had stopped being used. They often become a contamination source through leaching, runoff, or wind dispersion, just because of the mobility of the contaminant itself. And there is quite a high number of them. There is an estimate of over 60,000 sites in Alberta that might potentially be impacted by sterilants. But that's also not the same level as what we're talking about with hydrocarbons and just assets in general. So it's a big enough problem to be a challenge, but not necessarily a big enough problem to get the attention of the federal government, for example. I'd also like to point out that during this presentation, this is very much a collaborative program, and it has a lot of different moving parts in it and people that are involved with it. And I reached out to some of the collaborators for the program for some photos, and I got really great reception. So I want to give a heads up and a shout out to Millennium EMS Solutions, Advisian, and Nichols for providing a lot of the pictures for this presentation today. So what is the problem with sterilant impacted sites? For the most part, remediation can be stalled due to the challenging nature of the contaminants and the cost associated with conventional remediation approaches. So the contaminants are very difficult to treat to guideline level. Our guidelines have been established with very conservative approaches. They've been in the environment for a really long time, and so they can be quite widespread, and so delineation and chasing them with conventional remediation can be quite problematic and challenging. There's no single standardized solution due to the differences in chemical structure and environmental behavior of the products. And there's often confounding contaminant issues on these sites. So generally, if you have a site that's been impacted by one of the soil sterilants, you generally are also seeing contaminants that might be hydrocarbons or salts that you have to be able to figure out which one is going to be your most prominent in terms of driving your remediation solution. So when I got involved with this, there was a considerable amount of work that had already been done over the last 20 years. But there were enough knowledge gaps that remained that it was really challenging to determine what the best options were for effective management of the sites. So that's where we essentially started. What do we want to be able to achieve if we're going to be investing in a research program associated with sterilants? So we started out by developing a collective understanding of the scope of the sites that are impacted by soil sterilants and the specific challenges associated with their remediation and management. So we went about doing that by individual consultations. So we started with some conversations with people who have a vast amount of knowledge with impacted sites. So people like Catherine Bessie, Alfred Burke, Gladys Stevenson, who were really instrumental in the initial phases of saying, okay, well, what are the knowledge gaps? What do we know? What do we not know? And this was a big part of Catherine Bessie's career. And she was looking to be able to pass the torch per se, so that we could continue to advance this file. And so she's been really instrumental in seeing it move forward. And we also started talking with folks who were dealing with the problem on a more current status. So Monica Brightwell with ATCO had been dealing with a lot of these contaminated sites and was at a bit of a loss for what the best possible strategies might be. And so in conversations with folks like that who are dealing with the challenges on a day-to-day basis, we were able to kind of hone out what the knowledge gaps were that were going to actually inform future effective management. So we did a literature review of what's been done that's relevant to Alberta. We incorporated a lot of paper documents that Catherine had kept in her closet, as well as folks like Sandra Landsberg, who had recently retired and sent all of her files over, as well as a number of other literature reviews that had already been done. And we hosted a couple of workshops in 2018, and the outcome was a conceptual program model. So we identified that with the increased emphasis on reducing liabilities in the province and aging sites that are relevant to sterilant impacts were nearing their end of life, that we thought that there was a good opportunity to partner to develop strategies and methods to effectively manage those sites. So that's where the opportunity was born. So we synthesized the learnings that we have from the literature review and the workshops that we had, and they provide a whole suite of really useful information associated with the 6 sterilants that were previously commonly screened for in Alberta. And you can find all of that information on the recently launched CCLM knowledge portal. So this is an initiative that InnoTech has been working on in collaboration with Environment Canada and Climate Change's NBCKC, which is a national initiative to bring together folks who have an interest in caribou, with NRCan's Canadian Forest Service, Ducks Unlimited, and NATE Center for Boreal Research. So those organizations got together to create a portal and inventory and mechanism to share resources that are publicly available, that are maybe a little bit more challenging to access without a common place to be able to do that. And so this CCLM portal is available. It's free, it's accessible, and all of the information from those respective organizations, as well as the land group from COSIA, is available on this site, and we're continuing to add to it all the time. So the portal right now is focused on boreal conservation, wetlands, and land management. And so I encourage all of you to take a look, and if there's resources that you'd like to see up and available on that site, to reach out to me as well. So what did we learn from the literature synthesis that we did? The majority of sterilant impacts in Alberta are associated with two sterilants, bromacil and tebuthyron. The rest of them that we're commonly screened for are only identified on sites like once in a blue moon. The sites are primarily located in central and southern Alberta, although there are some in the northwestern part of the province. Alberta Tier 1 soil and groundwater guidelines are very, very conservative and based on data that has been generated outside of Alberta. There's a lack of available information for use in risk assessment models that's relevant to Alberta conditions, and remediation technologies that have been successfully utilized to reduce or eliminate sterilant impacts require a little bit more research, either to evaluate new and emerging technologies and or to look at them at an operational scale. So the Soil Sterilants Program is a joint industry program that incorporates folks from TC Energy, ATCO Electric, and ATCO Pipelines, Alberta Innovates, and InnoTech. The purpose of the program is to establish proven, technical, and cost-effective strategies and best management practices for effective management of sites impacted by soil sterilants, ultimately with the goal of achieving regulatory closure. This is a very important component of our program, and it's at the center of everything we do. So for all of the work that's being done within the program, we bring it back to this objective. What is the outcome we are trying to achieve, and how is the activity that we're working on going to help contribute to that? And I think that that's what's going to lead to its ultimate success, is being very outcome orientated. The knowledge gaps that we've identified are associated with three key areas: identification and delineation of the contaminants themselves, risk assessment and management, and remediation. So we could essentially boil down the key knowledge gaps that, if addressed, would help to be able to achieve that outcome I just described into these three key areas. So the program was set up and initiated in 2019. It's a 5-year program. The scope is limited to challenges that are specific to Alberta and the two contaminants, bromacil and tebuthyron. The program has been structured with a steering committee at the top of the ladder. So the steering committee consists of the industry partners and Alberta Innovates and InnoTech at the committee level, who have complete decision-making authority. They are responsible for guidelines and policies and project approval. But one of my favorite parts about this program is that the steering committee is being informed by an expert advisory committee, which has been established as a volunteer committee that consists of folks from across multiple different disciplines. So academia, environmental consultants, environmental service labs, as well as AP and AER, and it's a volunteer program, and the amount of participation that we have seen in this group to help advance this initiative has been overwhelming. And so I'm very grateful for the people who have put their name forward to be able to help with this. And their expertise is valuable in a whole suite of different areas, from past experience with sterilant impacted sites, guideline development, remediation technologies, analysis, etc. So that's really, I think, what the foundation of the success for the program will be, because the steering committee has the ability to make very informed decisions from a scientific perspective. Project execution is being done by a whole suite of project service providers that I'm going to go into in a little bit more detail in a second. And at the end of the day, what we're going to do is we're going to synthesize the learnings from all of the projects within the program to provide best management practices and a toolbox approach for effective management of sterilant impacted sites. So as I mentioned, we are very outcome orientated within the program. Within each of the program areas, we have very specific outcomes that we want to see achieved through the program. And essentially, at the end of the day, we want to be able to determine if there are multiple different techniques or technologies that are applicable even at one individual site that might be applicable for effective management of it. That's where we're aiming for. So we have a suite of projects that are specific to each of the knowledge gaps that have been identified. So within the area of identification and delineation, there's 5 projects, and I'll go into each of these in a little bit of detail. Under risk management and assessment, there's 4, and then remediation, we have 3, which one of them does also include remediation demonstration at an operational level. So the projects these projects here are not in any type of sequential order. The steering committee made a decision at the beginning of 2019, when we got the ball rolling, which projects they wanted to see kicked off first. But with that being said, there is a bit of a sequential order to a point, because some information from one project is being used to inform other projects, and we need to make sure that we were starting the ones early on in the process that we're going to have the most value for the projects later on. So the steering committee decided to start with projects 6, 8, 7, and 9. So the title for those projects is up there, and they were all started in October 2019. An RFP was released to companies who had submitted an interest through an expression of interest in the program in I believe it was about June 2019, or actually it might have been a little sooner, and these projects were released in June 2019 for review. And essentially, the process that went through was the project service providers submitted proposals, the expert advisory committee reviewed them, made a recommendation to the steering committee, and the companies who are listed up here as being successful with them, or the project service providers who were selected to execute them. So for projects number 6 and 8, they were joined. It was determined that Advisian, in collaboration with BV Labs and the University of Guelph, would execute those 2 projects, which were really about identifying the parameters that needed further evaluation to inform Tier 1 and Tier 2 models. And then evaluating what those look like in the field. And so they're actively working on that project. Number 7, risk assessment for freshwater aquatic life as well as irrigation water is being completed by Millennium EMS Solutions, led by Corey Karts. And phytotoxicity evaluation associated with bromacil and tebuthyron for native species is being done by Sarah Thacker at InnoTech. Some of the other projects that just launched more recently, a call for proposals was open to everybody to apply for projects 3, 4, and 5, which was more around lab methods and detection technologies. That was released in November or October 2019, and we're just kicking those off right now. So the lab methods component of the program is being led by Alberta Pereira at InnoTech. Bioaccessibility versus total sterilant concentrations is being completed by a university student at the U of A in Sylvie Kido's lab. And this is a cool project because this one is intimately linked with project number 10, which is something that is being done to evaluate the effectiveness of the most common remediation technology that's been applied to sterilant impacted sites, activated carbon. But the regulator is quite reluctant to consider that technology for long-term closure and certification because they're not sure of what the long-term bioaccessibility of the contaminant might be. And so this project is looking at developing a methodology to compare what amount of the contaminant is bioavailable, which means right now, immediately, versus bioaccessible, which it will come available at some point in the future, versus the total concentrations, which is what you get when you send it to a lab. And so that's a pretty big difference when you're looking at immobilization technologies. So I'm pretty pumped about that project. And Vertex Environmental, Kevin likes me to say these are the Ontario Vertex, is doing a field screening technologies project where they're evaluating a whole suite of technologies that might be available and applicable for detecting sterilants in the field. So if any of you have worked on any of these sites, you know that analysis is crazy expensive. And so we'd like to be able to bring that scope down a little bit so that we can have better delineation of the contaminants in the field. Project number 10, which is the one I was just mentioning, is investigating the long-term effects of activated carbon. And this is being done in collaboration with the university and InnoTech. There are a suite of sites that have had activated carbon applied up to even 30 years ago to more recently that we want to evaluate what the long-term effects actually are. And so that project is very much reliant on the methodology for project number 4, and it's sort of just getting kicked off now. And then there's the emphasis on the remediation technologies themselves. So that is sort of yet to be determined. We don't have any of those initiated yet, but hope to be able to start with some proof of concept projects with remediation technologies in year 2 of the program and demonstrations in year 3 of the program. So really quick update on the projects themselves. I'm sure there's people on the webinar today that would do a better job describing where they're at with this project themselves, but I'll do my best. Progress to date on this one, a sensitivity analysis of the tier 1, tier 2 models was completed by Advisian, and that informed experimental design for what we're going to be evaluating to get more specific information for Alberta. So we're going to be evaluating half-life and KOC values, the breakdown metabolites from the experiment itself. And we're doing that with coarse and fine textured soils under, temperatures that are relevant in Alberta conditions. They've also completed a metabolite breakdown product review so that we know what we're looking for when we are doing assessments out in the field and not just the pure products themselves. And they have completed an experimental design that has gone through review with AEP and AER to make sure that that is going to be accepted by the regulator when we're finished with completing the experiments themselves. Project number 7 is risk assessment for irrigation water and freshwater aquatic life being completed by Millennium. They are doing an evaluation of the tier 1 model and exploring alternative models for application that might be relevant. They were incorporating the findings from projects number 6 and 8 in terms of the sensitivity analysis into it. So really what we're able to do is capitalize on the work being done through multiple different projects to ensure that all of the moving parts can come together at the end of the day to achieve that outcome that we're looking for. And so I just received this this evaluation, I actually haven't read it all in detail yet. So this one is on track and moving forward as well. And this is what their general findings to date have been. Project number 9 for phytotoxicity evaluation, data for acute testing has been collected and is being used to define the definitive tests. The definitive tests are getting started right now. Measurements in the acute tests included shoot height for living plants for bromacil and tebuthyron, and that was completed in early to mid-March. Preliminary results, germination was not greatly impacted by increasing concentrations. However, the toxicity of the contaminants increased over time. And so the protocols actually need to be modified for native species for these contaminants to be longer than what's recommended in the typical protocol. So what's next? We're going to initiate the remaining projects that we have slated for 2020. And we're going to host an annual workshop to be able to share the learnings with people who are participating within the program. And that's going to get kicked off in March 2021. And knowledge synthesis and dissemination, whatever is written and publicly available, will be released through the CCLM portal, and then of course through the workshop itself. So with that, my contact information is here, as is Simone's. So if you have any questions, I'd be happy to take them.
Thank you, Bonnie. That was great. If you have questions, please, you can type them in the question feature of the thing. Do you want Simone to answer any questions? I know she's online.
I think she is.
Yeah, she's welcome to turn on her camera and say hi to the group.
Working on it.
There's Simone.
Hi,
Hey, Simone.
Does anyone have any questions? Please and thank you.
I think Bonnie mentioned that we're, looking for the latest technologies that may be applicable. So if anybody has ideas or have heard of something or have something in mind, by all means reach out and let us know, and we can put that onto the list for consideration.
Great. And their contact information will be on the slide deck, the PDF version that'll be posted on our site as well. Well, it doesn't look like there's any questions. Okay. Nope, there hasn't been any yet, so that's good. So thanks, Bonnie and Simone and InnoTech and our sponsor, Core Environmental Consulting, for making this happen today. Oh no, I got a thanks, Bonnie, from Jim Purvis. So that's the only question I have, which was a comment. So, thank you again.
That makes it easy for me.
Oh no, and I got great presentation. Looking forward to the results from Darcy. Oh, we got a question. How far north have you been working, just considering the options for companies working in the north?
I guess it depends on what you consider north. Right now, the program isn't field orientated. The work that we're doing is primarily in the lab and the greenhouse. We have compiled information for a number of sites that I would say the majority of them are definitely in south central Alberta. And then if I were to estimate the sites that we do have heading up into the northwestern part of the province, still primarily in white zone type of conditions, I would say we're probably as high equivalent as Slave Lake, I guess.
Okay. Okay, now there's no more questions. Oh wait, of course, as soon as I say that. What other remedial technologies have been forwarded for consideration so far other than activated charcoal?
Yeah, so you can find that information of what's been done both in Alberta and internationally in the literature review that's on the CCLM portal. in Alberta, the way that we did it initially for who would be interested in seeing the projects is we put out an expression of interest in 2019. And the companies that put that forward, I'm not sure if I should be throwing their names out right now, so I'm not going to do that. They essentially are hoping to see the rest of the RFPs, but we're looking at technologies from chemical, chemox technologies, ex situ technologies, bacterial technologies, other types of immobilization technologies. Simone, have I covered that list primarily?
For the most part, I would just throw in as well that there's assessment technologies as well, because assessment is really one of the big challenges. So both lab and field screening.
Okay, good. And I'll also include on the where the presentations and the recordings are, I'll also record, I'll put a link to the knowledge network up there as well for everyone so that everyone has that. So I think with that, we'll close off the webinar. So thank you again, Bonnie, Simone, InnoTech, and Core Environmental Consulting. Thank you, everyone. Take care.
Yes, thank you, Core.
Thanks, Bonnie.